like over there.
Now it's been a good day. Andrew.
Okay, while they're handing out journals, take a look at the learning target. So our learning target is I can solve multi-step problems using tools strategically. So your problem of the day question is, what does it mean to use tools strategically to solve mathematics problems? So this is something we've talked about all year long. We've talked about your tools. We've got our toolbox back there that's still covered up from our science test. Okay, so what does it mean to use tools strategically to solve math problems? So when you get your journal, open up to a clean sheet and answer this question on your problem of the day. Is that all the journals that were there? There's several without. Okay, if you didn't get your journal back, then I just need to get out a sheet of paper. Chances are you may have taken it with you one day. So just get out a sheet of paper. Yeah. So what does it mean to use tools strategically? What do you think of it? Use tools strategically. What does that mean to you? Okay, so that would be a strategy, right? Okay, so that's something you could write about, right? Okay. Is there only one answer to this? No. Several different answers possible. What does it, I'm asking you what it means to you. Okay? Not what it means to me. Not what it means to Miss B. Okay? What it means to you. What do you think? Okay, so you don't know what strategically means. That's a good point.
Yeah.
So it's a what? So what is a strategy? So what's a strategy we could use? What's a strategy we use in math? Division. Okay, so that's a strategy, right? Okay. So if you're going to use things strategically, if you were addition problem, would you use division? So would that be a strategic use of a tool? No, it wouldn't, would it? Okay, what if you were solving for x and you had 3x equals 21? So 7 is x, but how did you know that? Okay, so 3 times 7 is 21. So you use, in this case, you use mental math as a strategy, right? Did you have to go through that whole process of dividing by 3? Because you were able to use mental math in this case, right? So that's a strategy. So what would it mean to use tools strategically to solve problems? What would that mean to you? Well, think about the examples I just talked about, okay? What does that mean? I'll give you about 30 seconds. Finish up. Remember, keep your book open when you finish. All right, so let's talk about some of the stuff that came to your mind. Sheldon. To do it? To use them how you need to. To use what how you need to? The tools, okay? What would be an example of the tools that we have? A calculator would be a tool, yeah? A ruler, okay? Uriel, you got one? A scale. What else? The cubes, the tiles, okay? Does it have to be a concrete thing to be a strategy? No, it doesn't. What would be some strategies that aren't concrete? Addition and subtraction. Okay, what else?
Multiplication and division.
Multiplication and division. What else? Think about ratios and proportions. If we're trying to find equivalent fractions with ratios and proportions, what do? We do something up or we do something down?
Up.
Huh?
Up.
Starts with an S. Scale up, scale down. That's a tool, right? Andrew?
I could use tools in a way
Way they can explain it or they can be used to your advantage. Okay. What about a number line? Is that a tool?
Yeah.
Yeah. Is when you're solving for x, what would be something that what would be a strategy that you would use for solving for x, Uriel?
Multiplying.
Multiplying. So what would you multiply in this case?
X.
How would you use multiplication? So you would multiply x?
Multiply the number by
What number? What's the name for that special number?
letter.
No, that's the letter.
Constant.
Not that one. That one you usually add or subtract, right?
Yeah.
So what's the one that you usually multiply or divide? It's in orange up here.
Coefficient.
Coefficient, good. Okay, so dividing or multiplying by the coefficient to get to x, that's a tool. That's a strategy. So all of these things that we have been doing are strategies. So we're going to take all these strategies and now we're going to apply them to word problems. Okay, but first, before we get there, let's look at our agenda for the day. So we're going to do a solving equations activity, and I've divided you based on your test scores to provide some differentiation in the classroom. Okay. Next, we're going to talk about picture algebra. So you've heard us talk in math classes. You've heard us talk about concrete activities and presentational activities and abstract activities. So this is going to be the representational part of solving an equation. So we've used the hands-on equations. Which one would that be? What do you think? Concrete, representational, or abstract? Hands-on equations, we have something in our hands, right? So that'd be concrete, okay? So that's the concrete part. So today we're gonna talk about picture algebra, which is our representational, and then we're gonna take that picture algebra and we're gonna translate that into the written equation, which would be our abstract. Okay, so you're gonna see how all of that kind of comes together. So picture algebra into writing equations, and then we'll have an exit slope at the end. Okay? So what I need you to do is I'm going to give you your groups. You're going to, you don't even need a pencil for this. Okay? So you're going to take your belongings. When I say go, you're going to take your belongings, you're going to put them right up here at the front of the room, like we normally do. And you and your partners are going to find a place to work. Okay? So let me give you your groups. Then when I say go, you put your stuff up and you find your group. And then I'll explain the activity from there. Okay, group 1 is Yuli, Blake, and Kayla. Group 2, Alexis, Sheldon, Loretta. Group 3, Andrew, Uriel, and Karina. Group 4, Alex, Kaylin, and Valerie. Group 5, Jacqueline, Brenda, and Sarah. Group 6, Layla and Tristan. And Group 7, Trenton and Bella. Is there anybody's name I did not call? Make sure I didn't leave anybody out. Okay. I'm going to give you 30 seconds. Go. Five, 4, 3, 2, 1. So everybody's with their groups? Awesome. You guys did great. Okay, so let me show you what we're going to do here. So you're going to get 3 different bags. And all of them, something similar to what we did. This is going to be kind of... There we go. Alright, so this is similar to what we did in stations when we were reviewing for our test. But we don't have to give the properties. So what you're going to do is you're going to choose an equation. So say we chose the 6 subtract 5x equals negative 29. So say we chose that one to start with. What would be our first step in solving that equation? Uriel?
We have to subtract the number to be.
Okay, so which number would we subtract? The 6? Okay, so I'm going to find the one that says subtract 6 from both sides. I'm going to set that underneath. What would be my next step? Sarah?
To subtract 6 and negative 29.
Okay, well, we've already done that. Okay, so that's what the subtract 6 from both sides is. So what would be our next step?
You do 5x divided by
Okay, are we going to divide by 5x?
negative.
Negative 5. We're going to divide by negative 5, right?
Yeah.
Okay, so we're going to find our card that says divide both sides by negative 5. And you know what? You are going to need your journals and a pencil. I lied to you. Because you have to find the solution. Can you look at that and tell what the solution is?
No.
No, because you're probably going to need some paper and pencil. So we'll finish this and then I'll let you get your paper and pencil. My fault. Alright, so then the next step is going to be to find your solution. And I'm not going to show you what the solution is. I'm going to leave that up to you. So, there are several equations in each bag. You're going to do all of the equations in the bag, and then you're going to move to the next bag. You're going to start with the blue bag. Maybe. Okay, the blue bag is just integers. So you're going to do the blue bag, then you're going to do the green bag, and then you're going to do the pink bag. So they start easy and get progressively harder. So the blue bag is integers, just dealing with integers on it. The green has some simple fractions in there for your coefficients. And the pink has more complex fractions. So maybe instead of 1/2 x, it has 4/5 x. So you have to decide what to do there. Okay, are there any questions? Okay, while I'm bringing the bags around, why don't you guys go ahead and get your journals and a piece of pen.
I got it back here. Where? Right here? Back here. Okay, so once you get your stuff, you can go ahead and get started. If you guys want to, you can scoot here. Or you can go behind the table, see how she has more work, okay? You can scoot this over. Oh. Okay, so does every group have packet? Okay. All right, let's go.
You gotta go subtract the 10 from the 42 that one makes. So you grab this one and put it right here.
So subtract 10 from both sides, right?
Put it here so you can see it. 10 from both sides.
Yeah.
Then you're gonna divide it on.
You're going to divide by 2.
You can put another thing near this. Then you're gonna do the solution will be like 10, 40.
Let's write it out on our paper.
Equals 30.
You're going too fast. We need to put it on paper.
Okay, so what would be your first step?
Stop going so fast.
You're going to divide first.
And no, that's not.
What's the first thing that we always start with? On two-step equations.
Oh, you forgot we have to divide, not subtract.
We start with the constant.
2, 4, 6,
Because essentially what we want to do is we want to combine the like terms, right?
3, 4.
So the so if we have a constant here and a constant here, then we combine the like terms. So if we want to move -7, if we want to make this go to 0, what do we have to do?
Equals X.
Add 7. Okay, so do we have
Okay,
a
so
card that says add 7 to both sides?
42 equals 10 plus 2 times 16. So 2 times 16 is
Oh.
32.
Okay. So now what's our next step, Tristan? The step you always want to
2
do.
equals 10 plus 32.
Divide both sides.
10 plus 32 equals 42.
So now on your paper,
42.
do those steps and see what you come up with your solution. So your solution should be
Next one is 6. We already know how to do this one. She put this one on the board. Let's write 6 on both sides. Divide by 3.
I don't know what you got. That's your first one.
No, it's not.
See how it works?
I saw the answer over there.
Okay. Okay, so where's our subtract 6 from this side?
Is that instead?
Okay, so there's our subtract 6 from both sides. Now what's the next thing we do?
Then you do 5, negative 5, and negative 5.
That's negative 5x, right? You can't lose your coefficient.
And then that will be
Now this is negative 29 and negative 6.
Oh, you add them.
Mm-hmm.
Oh. 35.
Okay. Is that going to be positive or negative? Okay, so where's your divide by negative 5?
Divide by negative.
Okay. Alright, so now if we divide both sides by negative 5, what is our solution? X equals what?
X equals negative 35.
No, you got to divide negative 35 by negative 5.
Oh, 7.
7. So do you have a card that says the solution is 7?
Yeah.
There you go. So that's your first equation. So do you see how that works? Sort of? Okay. No, I want you to work together. Okay? I want you to work together on this because I want you to help each other out. Okay? Alright, so you guys start on another one and I'll come back and see how you're doing. Okay? So you can set this one to the side now. Alright?
We're missing one.
No, you put that on there. Well, yeah, you can place that one because
Hey guys, make sure that you get all of them separated. Sometimes they like to stick together. Good. So which one do you want to start with? This one? Okay, so what do you do first? Okay. What do we do? What? Instead of 3?
No.
Oh. What do you call it?
So you guys aren't in the same team.
And then you divide it by 3. And then x equals 6.
So let's work it out. Why don't you all do it?
We got negative 4.
That way you all do it.
I'm not free.
That's why we're here.
So the first thing we would do
Subtract 10 from both sides.
So since negative 7, and if you add
you add a positive 7, here equals 0, so we would X that out. And then 2, it would equal 9, which means we would bring down 3, so we would divide both sides by 3.
And then those will go together. We're done.
6, 28. 32. That's 16.
Yeah.
Alex, she was right. I know, I'm always right.
Alright, so we can set this one to the side now, and let's choose a different one.
3x.
So, 7. Yeah, no, because there's already a negative 7. That will cancel out. 8, 9. So, 3x plus 9 divided by 3. Divided by 9. No, 2 or 3. 3. 6 and 3.